Welcome to Structural Dynamics class. In this class, we will discuss about response to arbitrary force. So, outline of this class is arbitrarily varying force, response due to unit impulse, response to arbitrary force, and then we will discuss some problems in that. Now, if you look at this arbitrarily varying force acting on the structure. So, arbitrarily varying force means, like so far what we have discussed, a structure is there and on that we have applied sinusoidal force or a harmonic force we have applied. And now instead of harmonic force, if some random force is getting applied on that, say for example some wind force is acting, earthquake force is acting, how do we evaluate the response using the principles of structural dynamics. So, that is what we are going to discuss in this class. So, if you look at this equation, this is the equation of equilibrium, that is mu double dot plus cu dot plus ku is equal to p. So, this p usually is sinusoidal. So far what we have discussed was sinusoidal force. If sinusoidal force is acting, so we could able to find out the response. But instead of the sinusoidal force, if arbitrary force like this is acting, which is random in nature. So, if such kind of force is acting, how do we find the response from the principles which we have already studied? Okay, in single degree of freedom system, undamped free vibration, damped free vibration. So, using those principles, how do we understand this one? So, let me explain you the concept of this one. So, the concept of this is, we will first try to divide this arbitrary force. So, whatever manner it is, something like this, arbitrary force P of t and t. So, we will take this force at some time. So, this time we call it as say tau. At tau we will take that, and the distance gap between these two is d tau. So, tau and d tau. So, this becomes say impulse. Impulse is nothing but force multiplied by time, that is called impulse. Now, initially what we will do is take the response due to that impulse, only that impulse, find out the response. Now, where this impulse is acting, this impulse is acting at tau. So, that response due to impulse which is acting at that point, we call it as h t minus tau. So, that means what? Say if a structure is there and this force P of t is acting on this one, this is a full force, but this impulse is acting at tau. So, that means before this tau value there will not be any response. So, if I plot the response of this system, so the response of that system, this is response h t minus tau, response will start at this point only because of the impulse. So, before understanding the response due to impulse, we let us try to understand the impulse which is of one unit value. Yeah, this is response. So, this is impulse. So, in the larger arbitrary force we have subtracted, we have taken some small bit of force, that is impulse, and this one we are calling it as response due to unit impulse, only this much value. Okay, when it is acting here, so how the response will look like, and then after this one we will multiply it with the total impulse value, that becomes the response due to this impulse, and then we will integrate all the responses, like similar responses due to similar such kind of impulses at the different locations. So, that is what we are going to study in this class. Now, let us continue. So, response due to unit impulse. So, very large force acting for a very small time with finite time interval. So according to Newton's law, applied force is equal to rate of change of momentum. So applied force P is equal to momentum at time 2 at time t2 and momentum at time t1. So mass into velocity at time instant 2, mass into velocity at time instant 1 divided by dt. So that time interval. So that is force and momentum principle. Now if I multiply this P into dt, so which is impulse, so change of momentum is called impulse, or force into dt is impulse. Now here we can, if we take this m as common, u2 dot minus u1 dot, so that means velocity at time 2 minus velocity at time 1, so that is delta velocity, so that is change of velocity. So change of velocity multiplied by mass is impulse, and force into time is impulse, that is equal to force into time is impulse. So as you can see here, delta t and this, so this is unit impulse, 1 unit, so we are making it 1 unit. So if force is equal to 1, P is equal to 1, the above equation, if that is 1, P into delta t value is 1. So P to delta t value into multiplied by delta t is 1. So that means 1 is equal to m into delta u dot. So from this we can get that u dot tau is equal to 1 by m, assuming that initial condition, that is initial velocity is 0. So u dot at tau value is 1 by m. So if this is 1, so delta u dot, which is u2 minus u1, so u2 dot minus u1 dot, so u1 dot is 0, so u dot tau is equal to 1 by m. So a unit impulse causes free vibration due to initial conditions. So what are the initial conditions in this one? So if it is undamped free vibration equation, we have displacement at time t is equal to 0 and velocity at time t is equal to 0. So this, and damped free vibration, that is e to the power of minus zeta omega n t multiplied by u0, that is initial displacement, cos omega dt, this is damped natural frequency, and u dot 0 plus zeta omega n u0 by omega dt into sin omega dt. So this is undamped free vibration response, damped free vibration response. So now in this one we need to use initial conditions. So due to impulse, initial conditions are like at till time t is equal to tau, there is no force acting on the system. So at time t is equal to tau, force is acting, so that impulse is acting on the system. So impulse is generating this velocity, which is equal to 1 by mass. So let the displacement due to unit impulse, that is h at any time tau, is this value. So h t minus tau is due to unit impulse. So 1 unit impulse is causing h t minus tau. So it means time, that is response at any time, okay, which is greater than tau value. So before that it is 0. So initial conditions are u0 is equal to 0, u dot 0, that means u dot tau is equal to 1 by m. Now if we apply this one and put in damped free vibration, so e to the power of minus zeta omega n instead of t, that is t minus tau, and this value initial condition u0 is 0, and u dot 0 becomes u dot tau, u0 is 0, so u dot tau by omega d sin omega d into t minus tau. So this shows that if time scale is given, so till time t is equal to tau, there will not be any response. After that response starts. After that response starts. As you can see this one, h, that is a response due to unit impulse applied at time t is equal to tau, that is equal to e to the power of minus zeta omega n t minus tau multiplied by 1 by mass omega d sin omega d into t minus tau. So similarly for undamped free vibration, so for damped free vibration is the response here, for undamped free vibration this is the response. So difference is this. So if in this equation also if we put damping is equal to 0, same thing we will get. So only difference is here, if say in this case if zeta is equal to 0. So that means what? If this is 0, this term will disappear, it will become 1, and omega d, which is equal to omega n under root 1 minus zeta square. So if zeta is 0, this term disappears, omega d will become is equal to omega n. So this becomes omega n. So essentially both will become same when zeta value is equal to 0. Now response due to unit impulse, that is ht minus tau, is given like this, and undamped free vibration, damped free vibration, both the values are given. So here we need to remember that the t value should be always greater than or equal to tau, and this is how response will be. Force of this one unit is acting at this location. So at this location, exactly at that time, as you can see the plot of these two things, the blue line is indicating the undamped vibrations. So we can call it as undamped free vibration, but to initiate this vibration we need an initial disturbance which is caused due to impulse, and here this is damped vibration. As you can see, damping is taking place continuously. That means vibrating energy is removed from the system. Now impulse. So till now what we have discussed is this, the response is due to unit impulse. So now if it is impulse value, some value is there, now how the response will look like? So if we find out first the response due to unit impulse and multiply with the impulse value at time t is equal to tau, so then we will get the response due to impulse. You can see this one, ht minus tau is response due to unit impulse. Response due to unit impulse. Now if we want response due to impulse, then we need to multiply with impulse value, force into dt, okay, the time interval. So this is impulse. So impulse value multiplied by response due to unit impulse will give you response due to impulse. So which is this impulse. So this is the impulse, and this entire thing is response due to impulse. So this du of t is written because this is only due to one impulse. So in any arbitrary force, if we take a large arbitrary force, in that there can be many impulses, series of impulses will be there, and this is response due to one such impulse. And then response to all such impulses, if we want, we put together. So that is integral of this du. If we take integral here and integral here, as you can see, integral of dut will become ut is equal to integral 0 to t p tau ht minus tau into d tau. So this is called convolution integral. Convolution integral, or this can also be called as Duhamel's integral. So it is a very powerful tool to find out the response due to any arbitrary force, just by decomposing that force into a series of small impulse values, and then find out the response due to unit impulse, multiply by the impulse value, and then integrate it over the time. So then we will get the response at any point of time. Okay, so you can see this response of damped systems to impulse. Now if we substitute this ht minus tau d tau, as you can see this is ht minus tau d tau damped systems, and this is for undamped systems. So 1 by m omega d multiplied by e to the power of minus zeta omega d t minus tau sin omega d t minus tau d is a response due to unit impulse. Now multiply by impulse value. So let us go back and look at it. Yeah, this one. This is damped free vibration response. So ht minus tau is substituted, that value, and then we get this entire response. Now how does it look like? So it looks like this. So this is response due to impulse 1, response due to impulse 2, response due to impulse 3, response due to all impulses put together. So if we have say a force like this, something like this, a force T Pt. So this is first unit impulse, this is second unit impulse, third unit impulse, fourth unit impulse. So what happens is this response at this location, okay, so we can get it as response at this point, then next one is response at this point, third response at this point, and fourth one is fourth response at this point. If we want to get response at any point, that is full u of t, so at any point you add this value plus this value plus this value plus this value, all put together we get that value. So at any point here we add this value plus this value plus this value plus this value, you get response at that point. So it can be positive or negative. So this is a total response we will get. So that's how we add all the responses. So in summary, what we have studied in this class. So in this class we have studied first how a response to arbitrary force can be computed or calculated. So first we take arbitrary force and divide that into series of impulses. So impulse value is p at tau time t tau multiplied by d tau is the impulse value. And then we have understood how to get the response due to unit impulse, 1 unit impulse. So 1 unit impulse will generate velocity equal to 1 by m. So 1 unit impulse. Then after that, after getting that initial velocity, so we take undamped free vibration or damped free vibration. In that we substitute initial displacement value and initial velocity value. So in this solution, initial conditions are implicit inside. So we are inputting the input conditions, that is initial displacement and initial velocity. So we can get undamped free vibration response, damped free vibration response for unit impulse. So after getting that unit impulse, that is h t minus tau value, so we will multiply that with the impulse value, that is p tau d tau, p of tau multiply by d tau multiply by h t minus tau. So we will multiply. So this is a response due to impulse. So for getting the response of the total force at any point of time, we add all such kind of impulses, so in the form of integral. So that is called convolution integral or Duhamel's integral. So that's a summary of today's class, and we will discuss some applications or some special cases related to this convolution integral in the next class.